So we want to find the interval and radius of convergence of this power series. So let's go ahead and apply the ratio test. So we're going to look at the limit as n goes to infinity of the absolute value of, first we're going to take the n plus 1 term. So we put n plus 1 in everywhere we see the n. And then we're going to divide that by the nth term. So that's going to be n over 4 to the n times x plus 1 to the n. And we want that to be less than 1 to have convergence. So we're going to try and find x's that make this less than 1. So here I have x plus 1 to the n, and it's times x plus 1 to the 1. So we can get rid of to the n part and cancel it with this one. And here if we flip this over, we would have 4 to the n over n. And then we could do the same thing. This 4 to the n would cancel with the n part of this and leave us a 4 down here in the denominator. So let's rewrite this, and as we do, we could bring this x plus 1 and this 4 that's in the denominator out in front. So that's going to be 1/4 absolute value of x plus 1, and then we have the limit as n goes to infinity of n plus 1 over n, and we still want that less than 1 so that we'd have convergence. So this limit is 1, so we'd have 1/4 times the absolute value of x plus 1 is less than 1. We could multiply both sides by 4, and so we have the absolute value of x plus 1 is less than 4. So we know our radius of convergence, and that's going to be 4. Now let's go ahead and express this as a compound inequality. So we have -4 is less than x plus 1, which is less than 4. And we could subtract 1 from both sides. So we'd have -5 is less than x, which is less than 3. So we have our interval, but we need to check the endpoints. So we're going to come back up to our original series, and we're going to first plug in -5. And so if we did that, we would have the sum as n goes from 1 to infinity of n over 4 to the n, and then putting in a -5, -5 plus 1 would be -4 to the n. And so we could separate this out, and we could make it a +4 and take the -1 to the n outside of here, and these would cancel. And so we could see that we have an alternating series, but these terms are not going to 0 because we're letting n go from 1 to infinity. So therefore, by the divergence test, this would diverge. So we're not going to include -5. Now let's take the series. We'll come down here to the bottom to do it, and let's see what it looks like when we put in a 3 for the x. So we have n over 4 to the n, and then we're going to have 4 to the n. So we can see that when those cancel, again, by the divergence test, the series diverges. So we do not include either end, and so our interval of convergence is from -5 to 3, not inclusive of the ends.